Okay, looking at trigonomic ratios to help find an unknown side in a right angle triangle. Okay, so we can see here that we're going to be using sine, cos and tan. So we have sine of theta is opposite over hypotenuse, cos of theta is adjacent over hypotenuse, and tan of theta is opposite over adjacent. And what we're going to be looking at first is finding the unknown side when the unknown is on the top of our ratio. So let's have a look at these three triangles we have here, and we'll see if we can see a pattern here somewhere. So for the first one we're looking at, we have x, we have 37 degrees, and x here is our opposite, and we have our hypotenuse. So straight away we know we're going to be using sine. So we would write it out as sine 37 degrees equals our opposite, which is x, over our adjacent, which is 25. Now you can see here that our x, our unknown, is on the top of our ratio, and if we were wanting to get x by itself here, we're going to make sure that we go back to our equations and look at what we need to do. So to move to 25 to the other side, we need to get it over there. We're going to multiply both sides by 25. So times that side by 25 and that side by 25. If we now rewrite this, you can see that the 25 and 25 on this side cancel each other out, and we're just left with x. And then on this side here, we have 25 times sine 37. Okay, and so x equals 25 times sine 37. When you put that into your calculator, we'll round it to one decimal place. You would go 25 times sine 37 degrees, and you'll end up with 15.0 centimeters. Okay, let's look at the second one here. We've got again 37 degrees, but this time we have the adjacent side and the hypotenuse. So we're going to use cosine this time. So we're going to go cosine of 37 degrees equals our adjacent, which is x, over our hypotenuse, which is 25. So again here you can see that our unknown side is on the top, and so we need to get rid of our 25 so that x is isolated and we can work out what x equals. So again we're going to times both sides by 25, so they will cancel out, and we'll end up with a equation of x equals 25 times cos of 37 degrees. Now when you put this into your calculator, you're going to go 25 times cos 37 equals, and you will round that to one decimal place, and you'll end up with 20.0 centimeters. Okay, what do you think the last one's going to be? Let's have a look. So this time we have our degree of 37, we have our opposite, and we also have the adjacent. So we always know whenever there's no hypotenuse, so there's no length on the hypotenuse, it means that we're going to be using tan. So this one here, we're going to write tan of 37 degrees equals our opposite, which is x, over our adjacent, which is 25. And again, you can see here that our unknown is on the top. So we're going to do the same thing again here. So we're going to times by 25, times by 25. They cancel out, and our new equation is going to look like this. X equals 25 times tan of 37 degrees. And when you calculate that one, it'll work out at 18.8 centimeters. Now you can see here, let me just have a look at all three of them, that we've done the same process in all three of those by multiplying the bottom of our ratio to move it across to the other side, so we can isolate the unknown and work out what its value is. So we can do a little note here that says the unknown is on the, when the unknown is on the top of the ratio, just here we can write, we multiply. Okay, so just remind yourself that whenever the unknown is on the top of the ratio, we multiply. Now let's have a look at these bottom ones here. So the 3 we have at the bottom here, again, sine, cos and tan. And this time the unknown is on the bottom of the ratio. So we need to do something different here. So let's have a look at the first one here. We have our opposite and our hypotenuse. So we know we're using sine. So we're going to write sine of 41 degrees equals our opposite, which is 12, over our hypotenuse, which is x. Now, there is a long way to do this and a short way to do this. I'm going to show you the long way first. I'll just change the color so you can see. So if we were going to try and isolate the x, we would need to move it to the opposite side. So what we could do is multiply by x, and we would end up with x times sine 41 equals, and they cancel out, which would give us 12. But we want this x on its own, so we would then do the opposite to this one here. So we would divide by sine 41 and divide by sine 41, which will cancel those out and would get x equals 12 over sine 41. Now that's the long version. So I'm going to show you the quick version. And if you use this each time, it will make sense for you. Oops, what have I done there? Let me just make that a bit smaller so that I'm not rubbing out everything. Otherwise I'll have to redo it all. Okay, let's see if that works. Okay, let's go again. So this time I'm going to give you the trick. All we have to do is when the unknown is on the bottom, we're going to swap these over. Okay, so swap, and then once you swap those over, you divide. So our note for going on the bottom is swap and divide. Okay, so let's have a look at that. So let's go ahead and do it. So if we swap the x and the sine 41, we're going to end up with x over this side equals 12 divided by sine 41 degrees. And that's exactly what we want. Then when you put that in your calculator, you're going to go 12 divided by sine 41 and round that to 1 decimal place, and you would have 18.3 centimeters. Okay, let's do the exact same thing for the next one. This time though, we have our adjacent and our hypotenuse. So we know we're using cosine this time. So we're going to go cos of 41 degrees equals our adjacent over our hypotenuse. Again, this time, remembering we're going to swap and then divide. So let's go and swap those. So we'll have x equals 12 divided by cos of 41 degrees. Okay, so when you put that in your calculator, you're going to go 12 divided by cos 41 equals, and rounded to 1 decimal place, you will get 15.9 centimeters. Okay, last one. This one here, we have, as you can see, our opposite and our adjacent, which is going to mean we're going to use tan. So we're going to go tan of 41 degrees equals our opposite, which is 16, over our adjacent, which is our unknown of x. Again, the unknown is on the bottom, so we're going to swap. Okay, and then we just rewrite it so the x is over this side, and we're going to go 16 divided by tan 41 degrees. Okay, pop it into your calculator, 16 divided by tan 41, and you will round that to 1 decimal place, which should give you 18.4 centimeters. Okay, so from this information, you should be able to see that anytime we have an unknown on the top, so all of these ones here, let me just highlight them for you so you can see them. All these ones here where the unknown is on the top, then we multiply the bottom denominator across. When we have the unknown on the bottom, then that's when we swap and divide. Okay, hopefully that's very helpful for you, and we'll do some practicing on our worksheets now. Thanks.